So make sure you follow along. So sinusoidal are periodic. Sinusoidal functions are periodic and apply to scenarios that keep on repeating over time. So some of the classic ones, Ferris wheel, classic question about a Ferris wheel. Anything that is circular is game, okay? Temperature tracking over a full year, if you take the average temperature, it would always do like a sinusoidal periodic function, okay? The depth of the ocean tide, if you kept track of the ocean level, the water level, it would go down, right? And then it's almost a 24-hour cycle, by the way, not perfect, but that is cyclical. Cyclical is another word. So reminder, A doesn't just mean amplitude for us anymore. It could also mean it is the radius of a wheel. It will be the radius of the wheel. Therefore, if you ever need to find the diameter of a wheel, you just go 2 times amplitude, 2 times A. What would you do if you needed to find the circumference? Circumference of wheel, what would you do there? You just go 2 pi times radius, but when we're dealing with sinusoidal functions, our radius is what? Is the letter A in our equation. So it's 2 pi A. Okay. So that's another one. If they ever ask, what's the circumference of this wheel or of this tire, that's basically what they're referring to. Period is the amount of units along the x-axis. Amount of units along the x-axis for the pattern to repeat. So here's the classic. I'm going to use a different color for this because some students have a hard time if they ask, the question asks, what does the period tell us in this particular case? It is the time, and notice that I'm saying time in quotation because it could be it is the distance, but most of the time it's time, for a tire to go from the lowest point to the highest point and then back to the lowest point. That's literally what one way of answering it. So you go from the lowest to the highest, then back to, that's a full cycle right there. If you come back to where you started, or you could start up high, get to the lowest, and then back to the highest. That would also be a full cycle. That's a period, right? And here's a wheel right there. So imagine that at the top here, you might want to use a ruler for this part, but at the top you have your max, the highest point, any point, if you make a dot, if you get to here, you reach the highest point in this scenario. So that's your max. And then this is your min. Okay, so max, min. So what is our amplitude here? Our amplitude is the median, the midline. Just so you know, median and midline can be used interchangeably. So if median throws you off, just go midline, sorry, mid line right under it. It's the same thing. It's the halfway mark. So this is the radius right here. This is the amplitude, the letter A, or radius in this particular case if we're talking about a wheel. So let's say there's a mark on this wheel at the very top and it starts spinning, it starts rotating. This would get to the, like if you think of how many boxes, 1, 2, 3, 4, 5, we count 5 this way, it would end up right here. Like it would rotate, hit the midline, it would take another 5. 1, 2, 3, 4, 5 to get to the lowest point. And then it would take another 5 to get to the midline again. And another 5 to get to the highest. And so if we were to graph the height of this dot above the ground, you would end up with a sinusoidal function like this. Isn't that cool? Okay, I at least think so. So this is a period, right? How many units is that period in this case? It's 5 times 4, right? It's 20 units long. It's 20 units long. Okay. All right. So this is just a visual before we get started. And remember, every single time there's A goes from the midline to the lowest. A always goes from the midline to the highest. So A doesn't go anywhere. Okay? It's always there. All right. So sometimes word problems don't give us the whole picture, so we need to kind of come in and paint the full picture. So if a sinusoidal function has a minimum of 2.8 and a maximum of 512, determine the midline, the amplitude, the period. I'm gonna, before I answer, folks, I'm gonna use the bottom part here and just say this is a min, right? So we're gonna label that 2.8 at the bottom here. And then there's a max right here, somewhere down the x-axis, and it's on the high end here. This is 512. So this is what? This is half a cycle, correct? Half cycle. So we don't have the full picture here, but we can use this using symmetry to figure out the rest. What would be the midline, the equation of the midline, if I only had this information here? You have a bunch of formulas on your study sheet. To get the midline, we go max plus min divided by 2. So do we have that information? Yes, we have the min and the max right here, the 8 and the 12. So by the way, we're always talking about the midline. You want to talk about the y values, okay? So I know that max and min are labeled as a coordinate, but in this particular case, the midline, we want to be using the y value. So 12 plus 8 divided by 2, that's 20 divided by 2, that is 10. Okay? So we've got our midline there. Amplitude. Do we have everything we need for amplitude? What is the formula for that one? Max minus min divided by 2. Okay? That's going to be a little crowded here. So it's going to be 12 minus 8 divided by 2. 12 minus 8 is 4, divided by 2 is 2, correct? Does it make sense that A is 2, that our amplitude is 2? I think so, because watch, the midline is the 10 right here somewhere. If we were to go up 2, we get to 12. If we go down 2, we get to 8. So it does make sense. Always check it. The period, do we know what the period is? The period is the horizontal, right? So from here to here, we know it's half a cycle, so we need to have the entire from low to low. So technically, if we use a red pen here, we're going to complete that picture to get to that point. But we don't need it, right? We don't really need it. Half a cycle, for period, I would just go 2 times x max minus x min. So I'm going to take this x value, subtract that x value from it to get halfway there, and I'm just going to multiply it by 2. X max is 5, x min is 2. That's 2 times 3. That is 6 units. Every 6 units, this thing is going to repeat itself. Okay? So this is 3, and this is 3, and combined we've got a 6. What would be the coordinates of this point right here, folks? If you start at 2 and you add 6 to it, that would be 8, 8. Okay, so I know that this line represents the 8 line horizontally, and I also know that if I add 6 units to my x value, I get to 8. So you actually came up with another point just like that. Okay, let's keep going. Let's start with an actual word problem where an equation is provided. I think this has never happened, but I saw it in a textbook, so I did do this. Do you notice this 0.5 there? That you can't even enter that into your calculator. It won't let you. If that ever happens, so I'm doing this with you, okay? I'm not saying I won't even do this on a test. I will just not do it, but at least you've seen it. We can rewrite it. 20 sine, and so if you go half times this, you get, I'll just give you the answer, 1.57075 t, and then half of negative 2.5 would be negative 1.25. Just notice something on my key here. Right? So please know that I just did this because I saw it somewhere in a textbook, and if they ever do that on the exam, which I've never seen them do that, you just that's the only step you have to do to make this work for you. Okay, enter this into, let's enter it into our calculator real quick. I want you to find your own window in all of this, okay? So what I do immediately, I just find my max, my mid, and my min without even them telling me about it. And you don't even have to show me the work there. I'm just gonna go 25 plus 20. That's 45 is the max. The mid is 25. And the min is 25 minus 20, which is 5. That is a pretty good indicator as to what I need for my y's. And the last thing I do is the period. You don't even have to show the work. You just do it on your calculator. You go 2 times pi divided by this, 1.57. 0.75. There it is. It's 4. Okay. Once we've done that, we're actually going to read the question and see what is everything, like what units are we dealing with and all of that. I'm going to try graphing it. Whoa, right? That's a lot. So I'm going to go to my x max. I always go a little bit into my negatives here. X max will be, I'm going to go 3 periods, right? So 3 times 4. That's okay for that. My window, my max in terms of y should be in the 50s. My min should be, I'll go -5. I want to see my x-axis. And then the 25 is my mid, so there we go. It's a pretty good graph. So let's see what everything is, okay? Where HT represents the height above ground in feet, so emphasis on the above ground, okay? Height above ground, and T is time in minutes. The ride goes on for 5 revolutions. 5 revolution means 5 cycles, okay? So we know that every single point in this on this graph is going to be minutes and the height in feet. Okay? Time and height, that's what we're comparing here. Determine the diameter of the Ferris wheel. So this is supposed to keep track of the Ferris wheel, right? Where the ride begins, his position can be modeled by the function. So we're dealing with a wheel. So the diameter of the Ferris wheel is 2 times radius, which in this case is 2 times whatever A is. So A is 20. So that's 40 what? What is our height measured in here? We're in feet, right? So make sure you add units so you get full marks. So we know that the diameter of this Ferris wheel is 40 feet, okay, from end to end. How high above the ground is Tom at the lowest and the highest points? Explain why this might be the case. So let's go ahead and find that. Where is the lowest point here? Can I use this one here? I don't think so, because it seems like the lowest point is a little bit on the left of the starting point. Time starts at 0. So I'm going to find this here. Second trace min. Sorry. Come on. Second trace min. So I'm going to go find it. You can do it the other method too, where you draw your horizontal line at the minimum. So the minimum is 3.85, and the max, I don't even need to do this, I know, I just realized, but I'm going to find that anyway. Second trace max, I will find this here. I know it is 45, but there's various ways to verify what you're doing. 1.80, and that's 45. So if you do it this way with the calculator, so the lowest is 5 feet, while the highest is 45 feet. Why is it that there's a 5-foot lowest? Have you ever been on a Ferris wheel? Does it touch the ground? There's always a bit of a ramp, right, that you go onto. So that's what I'm saying. There might be a ramp to go onto the ride, because they do ask questions like these sometimes, right? Hence the 5-foot minimum height. Okay? There we go. Determine the period. What does it represent in this context? Let's show the work anyways. Okay, 2 pi divided by 1.57075. You get 3.999, which rounds to 4. What is my period going to be measured in? What units, guys? Whatever is along your x-axis. What is your x-axis in this case? Minutes. So it takes 4 minutes for the cycle to repeat. Okay. It means, okay, that it takes 4 minutes to get from the lowest point to the highest, then back down, back to lowest. Okay. Can you see that? It's a little small. Sorry about that. Takes 4 minutes to get from the lowest point to the highest, then back to the lowest point. That's explicitly what it means here. Determine the y-intercept. What does it represent in this context? And why is it not 5 feet? So let's figure that one out. What is the y-intercept? How do you find it? We'll find it. So you got to go second, trace, value. You let x equals to 0, and there we go. So we're going to show that work. .02, and that's in feet, right? I'm wondering why I asked this. What does it represent in this context? Because it would be the initial height at time 0, right? I think I was picturing this. You ready for this? I wouldn't expect you to know, but I don't know. The Ferris wheel, it always comes down the ramp, then you go on, and then you actually always go up a little bit. You go backwards, then the ramp drops, and then it starts. And I think that's overkill. I think that wasn't a fair question. That's what I was picturing when I wrote this. So we'll just leave it. Okay. I think that's not a fair question. And we don't want to write an essay here, do we? I don't think so. Okay, so now graphing 2 revolutions, so 2 cycles. Okay. So it's a word problem. So now you need to be careful with the labeling. You need to have extra steps. You need to have time in minutes. Okay. This should be height in feet. And use the numbers you already have. I have 5 as my lowest. I'm going to see if this works out. 5, 10, 15. No, it's not going to work out. I know that already. 10, 20, 30, 40, 50. I'm going to have to go up by 10 to make this work. For 2 full cycles, I need to have either 3 highs or 3 lows, okay? So what time do I need to have here? You need to watch out for this. So it takes 4. Look at your graph. That helps as well. It takes, from here to here, it takes 4, okay? And I start at the highest. Look at this. I wrote this down because I was already doing the work. We start where? My first high here, it's 380. So it's about 4, right? So 4 plus 4, that gets you to 8. Plus another 4 gets you to 12, right? So I need to make sure I have enough space down here to make it all the way to 12. So 2, 4, 6, 8, 10. I need to add a little bit here. 12. There you go. And graph those lines. So this is the 5. This is the lowest. Your mid is 25. Your high is 45. So those are the 3 that you should always sketch on there. And my y-intercept is 6 point, so it's 2, 4, 6, somewhere here. 6. And I already know that 385 is the starting point here. Wait a minute, 380, not 5. 180.45, sorry. So this is 1.5, 180 is right there. I go to the top. Okay? And you got to do the calculator thing. I'm going to go 45, 25, 5. There you go. So I started here. I'm going to find the mid there. Why not? Enter, enter, enter. That's the high. Sorry, I meant to say this one here. So enter, then you got to cycle to the blue one. Come on, it's the other line. Between the blue and the black, there we go. 0.8025. So 0.80 is right about, this would be 180 would be that right there. And then find this other one here on the other side, right there. That's 2.80. So 2.80 is right about there on the mid. And you find your low. It's 3.80. So 3.80 is right about there. And there you have one cycle, okay? Approximately. And just keep that going. So from this one here, I'm going to label this one. This is 1.80. And this is 3.80. Just for you to have as a reference, 3.85. And this is 1.8045. Okay? So what are you going to do with the period on this one? You're going to add 4 to this. So you add 4 to this, that gets you to 680. This is 7, 680 is right about there. Close enough is good enough. What's that? Yeah, sorry. 580, so that means the point is off, right? Focus now. I can't focus with chit-chatting in the back. 580 is here. Gets me to that point right there. And then you go to the low here and add 5 as well. 4 I should say, 780. This is 7. 780 is right about there. And then just do this. That's not quite 2 full cycles, is it? Because that's 1, you need another 1. So this will be 580.45. This would be 780.5. Let's do one more here. Add 4 to this, that would be 980, right? Gets you to right about there. And then it did say 2 revolutions. It doesn't say where to stop. So it's kind of like a minimum of 2 revolutions. So we're just going to continue there and just go arrowhead there. But you most definitely cannot go past to the negatives here because time cannot be negative because then you lose marks. Okay? Sometimes it tells you to stop after 5 seconds or so, or 4, in this case, 5 minutes, 10 minutes, whatever. Okay. Where are we at time-wise? Okay. I'm going to ask you to try a word problem by yourselves. It starts on page 23 and on. I'm going to say 23 to 26. Give it a try. this is one thing I need you to remember. You already know a lot of the functions we use to find time or find height at a certain time, all of those things. So I want you to use that knowledge and apply it to the situation. The only difference is here you keep on going, okay? So if this question asked you what's the height after 4.5 minutes, what would you use in terms of the function? Don't pack yet. If I asked you the height after 4.5 minutes, what would you do? Second trace 1 for value, because I give you the time. You type in 4.5, and it will be somewhere. 4.5 is somewhere here, probably stop right about there. So you would actually know the exact height after 4.5 minutes of the ride, okay? If I asked you how long will this ride stay above 30 feet, you draw your line 30, right? And then you gotta find the 2 points and figure out how long that ride stays above that certain height, okay? So those are things I expect you, that's kind of like quadratics knowledge back, okay? We do that a lot of times in quadratics. So that being said, okay, I'm gonna stop the video here.